The Earth is covered by vast oceans, yet only a few of them inspire genuine fear among those who truly understand them. The Bering Sea is one of those places. It does not depend on legends or exaggeration to justify its reputation. Its danger is documented, its violence measured, and its history recorded in official reports, rescue logs, and maritime investigations. This is not a sea that only challenges the inexperienced. It tests seasoned sailors, advanced technology, and even modern science. The Bering Sea lies between Alaska to the east and Russia's Far East to the west. To the north, it narrows into the Bering Strait, a relatively small passage that connects it to the Arctic Ocean. To the south, it opens directly into the North Pacific Ocean, one of the most powerful and energetic bodies of water on the planet. This location places the Bering Sea in a unique and unstable position. It exists at the meeting point of two massive and opposing systems. Cold, dense Arctic air regularly moves southward through the Bering Strait, while warmer, moisture-rich Pacific air pushes. These forces do not take turns. They collide continuously. Because of this collision, the Bering Sea becomes a natural pressure zone. Air pressure can drop suddenly, storms can intensify rapidly, and winds can strengthen in a matter of hours. In many parts of the world, severe storms develop over days, allowing ships and aircraft time to react. In the Bering Sea, conditions can shift so quickly that forecasts become outdated before they can be acted upon. This alone makes the region exceptionally dangerous. One of the most important reasons the Bering Sea behaves so violently is its depth, or more accurately, its lack of depth. Large portions of the sea rest on an expansive continental shelf, with average depths far shallower than most open oceans. In deep waters, storm energy spreads downward and outward, allowing waves to disperse gradually. In shallow seas like the Bering, that energy has nowhere to go. Instead, it is forced upward, creating waves that grow steeper, taller, and more unstable. Sailors often describe these waves not as rolling swells, but as sudden walls of water that rise without warning and break with enormous force. As powerful Pacific swells move northward and encounter the Bering Sea's continental shelf, their speed decreases while their height increases. This process compresses wave energy and destabilizes the surface. Even moderate storms can transform into lethal conditions. This environment is especially prone to the formation of rogue waves, massive waves that exceed predicted heights and appear suddenly, often striking vessels before crews can react. The geological history of the Bering Sea further explains its unpredictable nature. During the last ice age, global sea levels were much lower than they are today. What is now open water was once a vast land bridge known as Beringia, connecting Asia and North America. Humans crossed this frozen corridor, animals migrated across it, and entire ecosystems depended on it. When the ice age ended and the ice sheets melted, sea levels rose rapidly. Water flooded the basin unevenly, shaping a sea floor marked by glacial scars, submerged ridges, and irregular terrain. The result was not a smooth and stable ocean bed, but a fractured underwater landscape that continues to influence currents and wave behavior today. Beneath the surface, the Bering Sea is far from uniform. Submerged ridges, sudden drop-offs, ice-carved channels, and remnants of ancient volcanic activity disrupt the flow of water. Currents do not move in predictable paths. They split, reverse, and collide. This underwater chaos contributes to surface instability and makes navigation difficult even with modern equipment. Instruments may function correctly, yet the sea itself behaves in ways that are hard to anticipate. Ice is another defining feature of the Bering Sea. It is not limited to a single season, and it is never truly absent. Even outside the harshest winter months, floating ice can remain, and freezing conditions can develop quickly during storms. In winter, large areas of the sea are covered with ice, turning already dangerous waters into a shifting obstacle field. Ice damages hulls, interferes with steering, and reduces a vessel's ability to maneuver. Combined with high waves and poor visibility, it becomes a constant threat. The water temperature of the Bering Sea adds another layer of danger. Surface temperatures remain near freezing for most of the year. In such conditions, human survival time in the water is extremely limited. Cold shock occurs almost immediately, muscle control is lost within minutes, and hypothermia follows rapidly. Accidents that might be survivable in warmer seas often become fatal here. There is little room for rescue or recovery once someone enters the water. Above the surface, the atmosphere remains equally unstable. The Bering Sea is known for rapid pressure changes, powerful wind shear, and explosive storm development. These conditions create weather systems that intensify faster than forecasting models can reliably track. Pilots, sailors, and meteorologists have long reported the same challenge. The environment evolves faster than human response. Fog is another persistent and dangerous feature. It forms when cold air moves across relatively warmer water, creating dense layers that can reduce visibility to almost nothing. In the Bering Sea, fog can appear suddenly and linger for long periods. It interferes with radar, disorients navigation, and increases the risk of collision. Ships have struck ice, other vessels, and even landforms under fog conditions. Here, fog is not an inconvenience. It is a serious hazard. The isolation of the Bering Sea magnifies every risk. The region is remote, with limited ports and vast distances between rescue resources. When emergencies occur, response times are long and conditions often prevent immediate assistance. What might be a manageable incident elsewhere can become a disaster here simply because help cannot arrive in time. Despite all of this, the Bering Sea remains heavily used. It supports one of the world's largest commercial fishing industries, major shipping routes, and offshore resource exploration. Thousands of people work in these waters every year, fully aware of the risks. And every year, some of them do not return. Modern technology has improved navigation systems, vessel design, and weather forecasting, yet the Bering Sea continues to resist control. Its storms form locally and rapidly. The shallow depths amplify energy. Its systems evolve faster than predictions can adapt. The sea does not behave like others. It follows its own physical rules. The reputation of the Bering Sea is not built on myth or superstition. It is built on measurable data, official records, and lived experience. Scientists can explain many of its behaviors, but explanation does not mean mastery. Understanding the sea does not make it obedient. The Bering Sea is violent not by chance, but by design. Its location, geological history, atmospheric instability, and physical structure combine to create one of the most hostile marine environments on Earth. This foundation explains everything that happens here. And this is only the beginning. In the next part of this documentary, the focus will shift from the environment itself to the real-world consequences. The storms that destroy ships, the waves that overwhelm crews, and the waters that leave no room for survival.